Hello, it's John again. Our next move on this, now that we set the timing, is to do the torque converter. So we gotta bolt the torque converter to the flex plate. And there's my, believe it or not, those are my torque converter to flex plate bolts. They're old set of flywheel bolts for the flywheel, that goes to the crankshaft. But I use that for my flex plate too. And once again, it's ARP stuff. So that's our next move. So the car's got to go back up in the air, and I got to torque down my flex plate. Okay, I'll show you when I'm done. See you soon. Hello again, it's John. Okay, flex plate is all torqued down, which is pretty tough to get in with my torque wrench. But it's torqued down 50 pounds. They're 7/16 fine thread, 7/16 28, I think. Anyways, they're definitely 7/16 fine thread. Okay, on these bolts, I want to show you something. Let me show you the flex plate, and maybe I want to show you some axles too. So let's get underneath the car again, and I'll show you a few things to look out for. Okay. All right. So there's the reactor plate and torque converter, and it's all torqued up, 50 foot-pounds. That's what I torqued those bolts to. So now you see that bolt. See the way it sticks out? It's an all flywheel bolt. Okay. When you're using a bolt with the head that big, you got to make sure that the flex plate bolts, that's what they are, those are flex plate bolts, don't interfere with your starter. Okay? You put the starter in, and if that bolt, which if it was interfering, doesn't grind your starter away. Well, you got to start this thing up, and it'll make a hideous sound if those bolts are hitting on the starter. Let me show you what I mean. Now, let's go look at my starter. I'll show you what I did. It's like everything else, everything's gonna have to be modified. Everything's gonna have to fit. Okay. See that? Normally that starter ring goes all the way around here. You can see where it's missing there, because I had to grind it. I ground it by hand so that the flex plate bolts wasn't gonna hit on the starter. This is all stuff you gotta look for. Okay. Gotta make sure flex plate bolts don't hit on the starter. Anyways, let me show you these axles. Get into it. These axles are from the drive shaft shop. These are the ones I was telling you about. They're almost like, I don't know, about probably $1,900 a piece. Anyways, so you can see that this, you can see that if you look at it, this is it's all chrome moly stuff. And there's the ABS rings I was telling you about. That had to be machined. So I machined that outer CV, and then I put the stock Mazda Miata ABS rings on it. And the whole underneath of this car has been all greased. That's what the red stuff is. So now if you look, this is a 28 spline 7.5 rear end with a 246 gear in it. That's what I'm running. But if you look at it, see this, that stub on bolts from that, and I do believe that's a 927 Porsche Universal. I do believe that's what that is. But that stub there on bolts, so if you're running 31 spline rear end, you just unbolt that, because right now that's a 26 spline, so you just unbolt that stub and bolt a 31 on, and you can run a 31 spline rear end. So with these axles, you can run a 7.5, you can run an 8.8 with the same axles. So that's, anyways, these axles are axles and CVs. I mean, it's not the axle you ever break, even from Martin's kit. It's not the axles. You'll never break the axles. It's the tripod bearing and the CVs that's going to snap. But the tripod, there's no tripods in this in these axles. That's been They got rid of it. There's no tripod bearings in there. But these are rated for 900 horsepower, so 900 plus horsepower. Now, if you counted the splines on these axles, I do believe they're 38. Believe it or not. But so that's what the axles look like. And like I said, the stubs all come off, so you can run a 26 spline or you can run a 31 spline. They probably even got stubs that are bigger than 31. They probably got 35 spline stubs if that's what you want to do. But anyway, so that's where we're at so far. So now I bolted up the flex plate, and I got to ponder upon it and see what my next move is on this car, and I'll let you know. All right, see you soon. Okay, hello, this is John again. Yeah, I guess the next thing I'm going to put on is spark plugs. Have to go in. I already did it. They're already in, torqued down. You guys know how to put spark plugs in. But you got to plug up the holes so nothing gets in the motor. And now I'm going to do the lower harmonic balancer pulley and the drive shaft. So I want to show you my drive shaft. Okay, this is the drive shaft. This is the biggest universal they make. It's a monstrous universal. Anyways, it's a aluminum drive shaft. This is by Denny's. The yoke is by Strange. It's a chrome moly yoke, and these are also the biggest universals that you can put. So that's the drive shaft. Good for 1,200 horsepower. So, like I said, put the drive shaft in. The drive shaft's not cheap. It's like, I think from Denny's, right around $1,000. So, but it's good for 1,200 plus horsepower. Yeah, he builds it for you, and it's just one thing you just put out of your mind. You don't have to worry about it breaking. So that's the drive shaft. There's the lower pulley. So we're putting those two things that are gonna go in next. Okay. We'll see you soon. Hello again, this is John from Poor Man's Garage. Just got through tightening down the drive shaft bolts. Drive shaft bolts on a 7.5 or an 8.8 or 12 millimeter. And it's a special bolt. It's probably a grade. It's hard. You buy the good bolts. Don't screw around. Come 4 bolts in a pack, and I don't know what they are. $20 for 4 bolts or whatever they are. You buy the good ones though. I think you can get them from. You probably get them from ARP or maybe Ford Motorsport. Anyways, so when you put the bolts in the rear end part, use red Loctite. Okay, put the bolts in with red Loctite. You can't get a torque wrench in there, so you got to use an opening. This is why I use this. And tighten down as tight as I can get them. Okay. And when you think they're tight, tighten them down some more. They got to be tight. That's why I'm wearing the safety glasses. So if I just so happen to break the wrench, that's how tight I get them. I tighten them down until they stop with red Loctite. So when you think they're tight, tighten them down some more. So, like I said, I don't fool her. I'd say they got to be, I don't know what they're supposed to be torqued down to, but you can't get a torque wrench in there. But my guess is at least 75, 85 pounds. So I guarantee they're at least that. Red Loctite, tighten them down as tight as you can get them. So you can't get a torque wrench in there. Pipe on it with a wrench. Tighten them down. When you tighten them down, mark each one that you torque down. Now you got to torque down these two and then these two. Okay. Put a dot on it so you don't miss one. You don't want to miss one. That's for sure. When you do one, mark it. And do the next one, mark it. In case you miss one, somehow, some way. If it doesn't have a mark on it, torque it down again. Okay, I want to show you what it looks like. show you what the bolts look like. Those are the bolts I'm talking about. Special bolt. If you probably go to a drive shaft place, will probably have them bolts. I said I don't know what grade they are. I'm sure they're grade 11. But and you torque them down. See how I got a mark on them. Torque them down. Check them. Keep torquing them. Torque it down as tight as you can get them. Red Loctite. Okay, that's where the drive shaft is in. Yep. Okay, we're getting there. Lower pulleys in. All right. We're getting there. Slowly but surely. We're not in any race to put this thing together. The only thing I want to know is everything's put together as good as I can make it. Everything's torqued down properly, and everything's, like I said, as good as I can possibly make it. So however long that takes, however long it takes. I ain't in any hurry, but it's got to be perfect. Okay, see you soon. Well, hello again. This is John from Poor Man's Garage. Okay, I'll show you how far I got. Right? Okay. This is kind of where we're at now. The drive shaft's in. The alternator's on. The motor plates are in. Alright. This motor plate's in, so power steering bracket's all in. Distributor's in. We timed that, you know that. So anyways, that's as far as I got today. So now I'm gonna start cleaning up the garage because I made quite a mess. So I gotta clean up the garage and start again. I think I'll probably won't be working on it until Monday. So anyways, that's where we're at. So far, so good. So there's an isolator that goes up top here. There's an isolator that goes in between, and then there's an isolator at the bottom so it doesn't vibrate. There's rubber isolators. So I'll show you what the rubber isolators look like. These are the 3 rubber isolators. Like I say, you can squeeze them. So there's an isolator, and then stainless steel plate at the bottom. So isolator at the top, and then goes like that. Isolator at the bottom. Anyway, so I got quite a mess. So I'm gonna have to start cleaning. There's the other one with the isolators there. Stainless steel bottom plate. Stainless steel nuts. So we're getting there. Here's my. I said I told you can't put an oil filter on when you drop it in the car, but so what I did is I cut this, and then I put it on there so that the block doesn't get damaged when I put it in. So anyways, yeah, this mess I made, holy crud. So anyways, we're getting there. So hey y'all, I'll see you soon. Well, good morning everybody. It's John from Poor Man's Garage. I want to show you what I've been kind of tooling on. Anyways, it's the motor plates that connect to the frame. I'm going to show you how these work. Show you what it looks like when it's all in here. Get this going on. Alright, so it's a better view, I guess, from here. So, See the isolators, and that gets bolted onto the. This is the passenger side cylinder head. Like I said, that gets. Well, I got 1/4 inch flat plate at the bottom and a quarter inch stainless steel angle iron welded on the side. And here's the other side. This one you can't see it because all my power steering stuff is in the way. Oops, sorry about that. You can sort of see it, bottom of it. All my power steering stuff is that. That's what it looks like at the top. So it goes into the motor. So anyways, there's the top of it. And there's the other side. So that's what I got. Now, I'm gonna go underneath the car and start working on some stuff underneath the car. Shifter linkage and reverse and neutral safety switch, stuff like that. Anyways, I'm going to get a cup of coffee. I'll see you soon. Well, hello again. I just had breakfast and coffee, so good to go. So, this is John again from Poor Man's Garage. We're getting to the exhaust section now. When you do an exhaust system for your Mazda Miata, you want to build it out of 304 stainless. You don't want to use anything else. If you use 316, it ain't gonna make too much of a difference. 304. You don't want to use it, not the 409 or 406, 304 stainless steel. Okay, this exhaust system that I showed you, I built it about 5 years ago. So to deal with the exhaust system, I built it myself. Anytime you're doing an exhaust system out of 304 stainless, the exhaust system must be purged. We call it purged with argon. Okay, so I don't care if you're MIG welding the exhaust system. I don't care if you're TIG welding the exhaust system. Proper way to do it is to purge it. Purge it with argon. What purging means is you got, say you're working on, I'll give you for instance, I'm going to grab a section of the exhaust. Purge it means, so this is a section of the exhaust. What purge it means is, so this thing, I made it all at 180. So I ordered a bunch of 180 degree mandrel bends and some straight. So I ordered 12 foot of straight and probably, I'm going to say 8 180 degree mandrel bends. And then what I did is I cut up the mandrel bends to how I needed the exhaust system to run. I started at the front of the car and built it to the back. That's how I did the exhaust. So what you want to do is as you make the exhaust system, you put little tiny tacks in it to tack it up in place as I'm building the exhaust system. And like I said, the exhaust system is the hardest part of this build on this car, is the exhaust system. Believe me when I tell you, everything else is cake except for the exhaust system. The exhaust system, you have to take your time. Little tacks, tiny tacks, tack it up. You gotta do the whole exhaust system. Don't just do a little section of it and then weld that, another little section, weld that, it'll come out bad. You gotta tack, everything has to be tacked up, 3 tacks. Okay, and then, so once you have a section, what happened is you have to take aluminum foil, this is what I do, I take aluminum foil and I cover this. And I take aluminum foil and I cover this. Now this whole thing's all tacked together. It's all tacked. And then I take the aluminum foil and where the section that I'm going to do, say I'm going to do this section, what I do is I take aluminum foil and I wrap this, and I wrap this, and I wrap. So all my joints are sealed. So I wrap it with aluminum foil and then I put a piece of tape around the aluminum foil. So now I'm going to do this section. And so I unwrap this section so this section doesn't, and this is tacked together. And you got to make sure when you're putting your sections together that they're tight. Okay? And then what you're going to do is you have to have a line running off your argon gauge. A separate line to purge the exhaust system. So I'll show you my my argon gauge setup here. So here's my argon gauge, and you see it's got two sides to it. Okay, it's got a side that goes to my TIG torch, and it's got a side that goes to whatever I want to purge to. All right, this is the purge side. So this is my line for purging. See, all it is just a plastic tube. So you run, so you got to separate the regulator and put a valve on it. And what you need is to purge it with argon. So what you're doing is you're getting rid of all the air out of the tube before you start TIG welding it, all the air out of the tube, and it's filled 100% full of argon. So now there's no air inside the tube. Then you start your TIG welding. You have to purge the whole time you TIG weld. All the sections of the exhaust system have to be purged. Have to be purged. Don't skip out on this, because what happens is when you're welding stainless steel, you don't purge it. What happens is it becomes crystallized when it mixes with the air. So when it mixes with the air, the stainless steel crystallizes. What happens is you put this exhaust system together without purging it. What happens is a month from now or a couple months from now, it'll crack because it's weak. The stainless steel is crystallized, which makes it very weak. So your exhaust system starts cracking. So you guys that got stainless steel exhaust systems out there, and they're cracking, and you keep welding them up, and they keep cracking, you keep welding them up, and they keep cracking. That's the reason why. Is because you didn't purge the exhaust system before you welded it. If you purge the exhaust system before you weld it, this exhaust system is 5 years old, it won't crack, ever. At least it never has for me, but you have to purge it. The outside weld, when you're done, outside weld, real nice, like this is 5 years old, that's why it looks like that. When you look inside of it, it should look, the outside should look the same as the inside, if you do it properly. It's got to be cleaned, no oil, no grease, no water. So when you do the sections, when they do the manual bends, they bend them and they put oil in them. So that's how they get them to bend. Or else they never get the inside die out. So when you get these manual bends, they're all full of oil, so they got to be clean. I clean my tubes in mineral spirits, and then I take the die grinder and I clean the outside with the die grinder with a cartridge roll, inside with a cartridge roll, blow it out, and it's ready to go. Okay. So exhaust system, you have to do that. Believe me when I tell you, you got to purge the exhaust system before you even think about one. Don't skip and say, well, I'm down on the last section, I'm not going to purge it. No, that's going to be where it bites you. I'm going to show you what the exhaust system looks like. And when you're doing the exhaust system, you have to put the flex stainless steel flexible sections in there. I don't know what they're called, but you can get them on eBay. They're made out of, it's like a stainless steel mesh, and then it's got an inside flex, stainless steel inside flexible section inside the flex hose. I guess they call it flex hose. Exhaust, stainless steel exhaust flex hose. You have to run 2 of them in there. What happened is I had a bad vibration. It drove me nuts, and I couldn't figure out what it was. I tried all kinds of stuff. Bad vibration, and it ended up being the exhaust. It was giving me the bad vibration, believe it or not. I know it sounds crazy, but it ended up being the exhaust that had the bad vibration in the car. It was like an 80 mile an hour bad vibration. I couldn't get rid of it, no matter what I did. And I had everything was all done. It ended up being the exhaust. So you got to put these flex sections in your stainless steel exhaust system. If you don't have the flex systems in there and you got a V8 Miata, I guarantee it's probably the exhaust system. That's where the vibrations come from. So anyways, here's what the exhaust system looks like. Okay. All right. Now these tips go here, and what happens is they go like this. This is made out of copper, and I should have made it out of aluminum. So my next ones are going to make them out of aluminum. So anyways, this gets bolted, clamped with a stainless steel clamp like that. All right. And what that does is it goes. This allows this exhaust system to move. Believe it or not, this exhaust system will go exactly a ½ an inch from front to back. It actually goes towards the rear of the car a ½ an inch. So when you're doing this exhaust system for a Mazda Miata, make sure that you have a ½ inch of clearance all around, or else you're going to be in trouble. You're going to have something knocking. The exhaust system's going to knock. So there's the flexible sections I was talking about. These are stainless steel flanges. I made the flanges, and this is copper gaskets. And when you put the copper gaskets together, I use this stuff. Muffler tailpipe sealer. So I put the exhaust system together with the copper gaskets. Copper gaskets go here between these sections. Everything's 304 stainless. And then I put that the muffler tailpipe sealer by Permatex in there, and then I let it set 24 hours. Okay. And I mean, I'll show you on the car that the exhaust system goes out the rear bumper. I mean, the exhaust system goes out the rear bumper. All right. So this is stainless steel. There's a stainless steel plate inside here that I made that goes the whole length. Stainless steel, I said, and that's so now that sleeve is able to move, because that exhaust system will actually move a ½ inch towards the rear of the car when you start up the car. So it fits inside here pretty nice and kind of holds it in place. It doesn't make any noise or anything like that. Doesn't rattle. But that exhaust system will slide this way, ½ inch when it's warmed up. But it looks really cool when it's complete. And I'll show you guys when it's complete. It looks really neat. And the hangers, I had to make hangers. So I got 4 hangers on the rear. 1, 2, 3, 4. So I'll show you the exhaust system when it's done. So that's where we're at with this exhaust system on the car. And shifter linkage, exhaust system, rear speedometer cable, and neutral safety lockout switch. And I also got a transmission temperature that goes inside the car. Tells me how hot my transmission is. Okay, see you soon. Another thing I forgot to mention, you have to put the right section on my car, which would be the passenger side exhaust system has to go on before you put the starter in the car, because you're not able to connect the bolts because you can't get in there because the starter's in the way. So the exhaust system has to go on before I put the starter in the car. Forgot to mention that. That's how I figured that one out. All right, I'll see you soon. Well, hello again. John from Poor Man's Garage. Okay, I got the front section of the exhaust system on. Means the 2 pipes that come from the header, they come down like that and then back. I'll show you. So before I go any further, I got to do my shifter linkage. Now this is automatic shifter linkage. So I'm going to show you how we're going to do that. Okay, let's check it out. Okay. Inside the car, you'll see my shifter. Let's see here, let me make sure. Yeah. My shifter is set for neutral. Okay. So it's set for neutral. So now basically what you want to do, you gotta remember that I already set this up, so. But I'm gonna show you some stuff underneath the car. So I already set the shifter up. So this is just a stock Mazda Miata automatic shifter that I got from the boneyard. If you look at it, see all those holes in it? Kind of looks like Swiss cheese. I drilled all those holes in it. So what it is if you don't have enough throw on your shifter linkage, what you do is to get more throw is you just take the rod and go down to the next pinhole that's closer to the bottom of the rod, and what that does is that gives you more throw in your shifter linkage. So if you need less throw, you go up farther, which brings it closer to the shifter, and if you want more throw, you go down further. So anyways, the shifter is in neutral. So now you want to set the transmission for neutral. We're going to set the transmission for neutral. Now how we're going to do that is, which is pretty tough holding onto the camera and showing you all this at the same time. It's a little difficult. Well, that's not a bad spot. So what I'm going to do is I just got this hand tight by hand. What I'm going to do is I'm going to see where the transmission is now. I think the transmission's in park. So let's check it out and see if it's in park or not. We'll do this by trying to rock the car. I believe it's in park. Now if it's in park, and I got my emergency brake off, which the emergency brake's on. So let's take the emergency brake off. Okay, now emergency brake's off. So now if this car moves, I know it's not in park. And it does. No, it doesn't. Nope. See? Oh, unless there's something under the wheels. No, nothing under the wheels I can see. Just gonna check it out. All right, let me push a little harder on it, make sure it's in park. Okay, definitely in park. Okay, so we know that's park. So transmission's in park right now. Let's go back under the car. Okay, so we know the transmission is currently in park, so that's all the way this way. So let's count. So that's park. Your next one is what? Next one would be, next click would be reverse. I went too far, so that's still back in park. One more click. It's reverse. Next click is neutral. Okay, let's just take this off. Let's double check this thing. I might have gone a couple too far. Let's take this off. So you know that's park. Next one is reverse. Next one's neutral. Okay, for sure that's neutral now. So let's put this linkage back on just like that. Now I'm going to go back to the shifter in the car and make sure the shifter's in neutral. Well, I get my grubby paws on the shifter now that I grease my hands up nice. Okay, now let's check it out. Let's see if we're still in neutral, which it looks like to me we are, but I gotta double check. Okay, it's definitely in neutral. That's what we want, right there. Now let's crawl under the car again. So I'll push this linkage all the way this way. So we definitely know that transmission's in neutral and the shifter's in neutral. I'm going to tighten this nut very carefully. so that I don't disturb the shifter. So I think it's 9/16. No, I think it's ½ inch. Okay, very carefully. Gotta tighten it without moving anything. Without moving the linkage, I'm gonna tighten her down. Yeah, just like that. Nice and tight. Well, let's get back into the car and see if we have all the gears. Main thing we want to do is to make sure we got park. Because if you park the car on a hill and you put the automatic shifter selector in the park and it's not actually in park, you'll find your car rolling down the hill and ended up somewhere where you don't want it to end up, like running some people over on the sidewalk or something really bad like that. So we don't want anything bad like that to happen. So the main thing is when I put it here, I gotta check and make sure that that is actually in park. Now it says park on the shifter select, but is it park on the transmission? Let's find out. Let's try to move the car again. Let's see where it's at. Biggest thing is, okay, that's definitely park. Okay, so let's see if we got all our gears. Okay, there's park. That would be reverse. That would be neutral. Remember, this is a reverse pattern valve body for me. It's a reverse pattern valve body because drive is now first. Second is second, there's second. And first is third. So I go down to shift up, I pull the shifter down. So that's just first, second, third. The reason is the worst I can do is skip from first to third and skip over second. I can't accidentally put the transmission in neutral, reverse, or park because you got to pull the shifter down. That's why they do it. It's a neutral safety lockout device, reverse pattern valve body. So this is first for me, this is second, that's third. We got all three gears. And we got park. So that's how we set our shifter. Oh. So like I said, a reverse pattern valve body. First is first, second is second, first is third. You can't accidentally put it in reverse or put it in neutral or put it in park because that would be really bad. So that's why I set that. That's why I set up like that. Okay. I'll see you soon.